Solving radical equations are very much like solving just basic equations, basic linear equations. You will start by getting rid of whatever is by the variable and then taking care of the variable at the end. So I'll start with your first problem, number 7. Number 7 is radical x plus 3 equals 5. So to solve this, you need to get rid of the 3. And the way that we do that is subtracting 3 from each side. So that will now give you radical x equals 2. To solve for x, we don't want the radical sign there. So to get rid of a radical symbol, we square it, and then we need to square the other side as well. So your final answer would be x equals 4. You also could have just done this problem in your head, and that's how we're going to check this. So what can you take the square root of and then add it to 3 to get 5? Well, if I substitute our answer in of 4, the square root of 4 is 2, and 2 plus 3 is 5, so I know I am correct. Let's do one that's a little more complicated, which is number 13. So for number 13, you have a few items underneath the radical sign. And you'll notice that next to the radical sign on the same side of the equation, there is nothing else that I need to get rid of. So our first step would just be to square each side of this problem to get rid of the radical sign. So I'm going to square and square. And the square root and the square cancel each other out. So I'm left with 3a plus 1 on the left. And 7 squared is 49 on the right. And then you would just continue this problem like you would normally, which is subtract 1 from each side. I now have 3a equals 48, and 3 goes into 48 16 times. I'm going to check my solution because the directions ask me to. So I'm going to plug in a 16 right here in the initial problem. So 3 times 16 is 48. 48 plus 1 is 49. And 49, the square root of 49 does equal 7. So I do know my answer is correct. The next section has radicals on each side of the equation. So it's just like the couple that we started with, but now you're going to have to square each side to get rid of each radical. So I will do, let's do 23. So I'm going to just put a square around each side of the equation, and those symbols would cancel out. So I'd be left with n plus 5 equals 5n minus 11. Then I need to move my variables onto one side and my numbers onto the other. So I'm going to move my n to the right side. So if I subtract n from each side, I get 4n. And then because my variables are on the left, you could put them on the right if you, I'm sorry, they're on the right. You could put them on the left if you wanted to. So because I've chosen to put them on the right, my constants or my numbers are going to have to go to the left. So I'm going to add 11 to each side. I get 16. And 4 goes into 16 4 times. So my answer is 4. But I have to double check my answer because sometimes when you plug these in, they do not work. So for 23, again, plugging it in, I would get 4 plus 5 is 9. And on the other side, I would get 5 times 4 is 20, and then a minus 11. So the square root of 9 is 3. 20 minus 11 is also 9, and the square root of 9 is 3. So my solution of 4 works. On the next page, you have some problems in this section that ask you to decide whether any of the answers are extraneous for each equation. What extraneous means is that if you plug them in, they will not equal each other on both sides of the problem. So in other words, if you were to solve this problem and you got those two answers and they worked fine when you solved it, when you plug it in, they may not both work. So I'm going to do 25. I'm going to take each solution separately, plug it in, see if it works. So I'm going to start with -3. So if I plug that into -z, that means the opposite of z. And the opposite of -3 is 3. So that's what I'm going to get on the left. On the right, if I plug in -3 for negative z again, I get 3. And 3 plus 6 is 9, and the square root of 9 is 3, so this one is a solution. I'm going to switch colors and use red, and now I'm going to plug in 2. So negative z would be -2. Well, hopefully you already know that the square root of something cannot be negative as long as you're in an algebra class. So I'm pretty sure that one's not going to work, but let's just keep going. So if I plug in 2 for negative z in the radical, I get -2. So 6 minus 2 is 4, and the square root of 4 is 2, which is not -2. So for 25, your answer would be z equals 2, because it asks you which one of these are extraneous, which means it does not work. That one did not work. So z equals 2 is extraneous. Our last section asks you to solve again, but this time you're going to get 2 answers in most cases, and sometimes they both work and sometimes they don't, just like the previous example. So I'm going to do 31. So to solve this problem, I will need to square each side to get rid of that radical symbol. So that will leave me with x squared on the left and 2x plus 3 on the right. It's been a little while since we've done this, but this is a quadratic equation. When we're solving quadratic equations, you could use a quadratic formula, you could complete the square, you could take square roots, you could factor. This problem is definitely going to be the easiest way to do this is going to be to factor. So I am going to move everything onto the left, which means 2x will become -2x. 3 will become -3, and I'm going to set it equal to 0, and then I'm going to factor. Remember, we always go to the back of the problem. Well, that's a prime number. The only thing I can break down 3 into is 3 and 1. And I'm trying to get a -2 here when I subtract these two numbers. So if I subtract these two numbers, that'd be -3 and a +1. So this would be -3x plus 1 would give me the -2x that I'm looking for. Remember that you set each equal to 0 to solve. So the chunk x minus 3, the number that makes that equal 0 is 3. And the second factor, x plus 1, the number that makes that equal to 0 is -1. So here are my two answers, but they may not both work. So I'm going to erase my scribbles over here, and I'm going to try them each. Well, if I plug in a 3, that would be 2 times 3 is 3, and 3 plus 3 is 9, and the square root of 9 is 3, so 3 does work. And then if I try -1, well, you know from the previous example, I'm going to have a -1 there. And honestly, it doesn't matter what this side equals. We can't have the square root of a negative number in algebra, so this is extraneous. So even though we solved it and we got two answers, 3 and -1, one of them does not work if I plug it back in. So your only answer for this would be 3.